Hello, this video is entitled Tire Fundamentals. This is another video in the training series of general information meant for all service professionals, whether you be tech, service advisor, or whatever, manager, whatever the case may be. This is foundational information for you to be able to do your job properly as well as communicate with customers properly. Now, this is not intended to be a comprehensive technical training video. So if you're a technician, you need to have a greater level of understanding of tires than what this video is going to communicate. But it is pretty comprehensive if you're going to be a service advisor or manager or something of that nature. This video will pretty much cover where the depth of your understanding needs to be. Obviously, the more knowledge you have, the better you can do your job, but this should get you the foundation you need to accomplish what you need to. The most important concepts in this video are going to be tire pressure, tread depth, rotation patterns, and wear patterns. Okay, those are the four most important concepts with tires, and in order from basic to more complex. So first of all, tire pressure, very straightforward. It's the amount of air pressure that's inside the tire. Where do we find the proper setting for a vehicle? Well, the manufacturer spec is the proper setting for the vehicle. The manufacturer spec should normally be found on an identification label in the driver's door jamb of the vehicle. Typically a white label with black writing. It will give you the factory tire size as well as manufacturer specified pressures for the front and the rear. Some vehicles will run a different pressure on the front than the rear. Some vehicles will even run a different tire size on the front and the rear. Tire size is probably something I should talk about too. I'll try to remember to hit that here at the end of the video. But back to tire pressure. The manufacturer spec is always the best. Now, you will run into certain situations where you may not want to go with the manufacturer spec. What am I talking about? Well, especially out here in rural America, there are a lot of people that will put 10-ply tires on a half-ton pickup or even an SUV. I've even seen them on minivans. If you put a 10-ply tire on an application that specifies a passenger car tire, you're going to have to deviate from manufacturer spec with your pressure, just like was done with the tires. Alright, good rule of thumb, you need to run a 10-ply tire at higher pressure than a passenger car tire, simply because of the way the tire expands. There's so much more rubber there. If you run it at passenger car spec, you're not going to get the center of that tread ballooned up like it needs to be. You're going to be like this. So in order to get proper road contact out of a 10-ply tire, you need to run more pressure. How much? That's when experience and making a judgment call comes in. But a good rule of thumb is, depending on the size and weight of the vehicle and the size of the tire, all those considerations, you should typically run somewhere between 45 and 60 pounds of pressure in a 10-ply tire that's on a light duty, half-ton or less vehicle. Okay, and you're just going to have to kind of use some common sense. The tech should be able to look at the tire and see if it appears to be properly inflated or not. But the rule of thumb would be 45 to 60 pounds. Okay, moving on. One last point on that. The pressure prior to adjustment should be noted on the tech's inspection sheet. We need to always pay attention to that. So, all right, tread depth. Quite simply, tread depth is the amount of tread that the tire has as measured from the bottom of the tread channels to the top of the tread using a tread depth gauge. We don't use pennies, we don't use quarters, we use a tread depth gauge. 230 seconds is the legal minimum across all vehicles. The one exception to that is commercial vehicles are required to have 430 seconds of tread on the steering axle. What is a commercial vehicle? Anything with a commercial plate on it. So it could be a 1 ton, half ton, 3/4 ton pickup and still be a commercial vehicle if it is licensed as a commercial vehicle. The best way to check that out is to know what your state's commercial vehicle plates look like. In Kansas, they're going to be the PWR, the power plates. And anything with that on it falls under DOT specs. DOT spec is that the steering tires must have 430 seconds of tread and drive tires must have 230 seconds of tread. So that's the only deviation from the 230 seconds being the legal minimum. 330 seconds is where we recommend replacement. Reason being, if it's in our shop and it's got 330 seconds and the next time it's scheduled to be in is its next oil change, it's going to be well below 230 seconds by the next time it's due for an oil change. So we're going to go ahead and recommend those tires, and then it's going to be a conversation with the customer in terms of when. The tires with the most tread should be on the drive axle. Now we're starting to get into some of the tire rotation stuff, which is our next subject, but the drive axle is going to wear tires more quickly than the steering axle, the non-drive axle. On a front-wheel drive car, that's the front. On a rear-wheel drive vehicle or all-wheel drive vehicle, well, not necessarily all-wheel drive, but four-wheel drive truck, that's going to be the rear axle. The reason I hesitated with the all-wheel drive, your crossover SUVs, things like that that are all-wheel drive are primarily a front-wheel drive vehicle. The rear axle is the auxiliary drive system. The front axle is the primary drive system. So it gets a little bit sticky when you're dealing with something like that, or a Subaru or things like that. They actually, the front axle is the primary drive axle. So we always want the best tires on the rear. The only exception to that would be as if it's a commercial vehicle. Let's say the rear tires are at 330 seconds. The fronts are at 5. We should rotate those tires, right, to get the best tires onto the drive axle, but not in this case, because if we do that, we are going to put that vehicle out of compliance with DOT specs, because we can't have tires with less than 430 seconds on the steering axle. So, know your specs. Generally speaking, you want the best tires on the drive axle, and that should get you where you need to be. Rotation patterns. This is the next subject. One quick thing I want to point out, going back to tire pressure and tire wear. This is going to be included in the documentation that goes with this video, the standard policy for the company, but I want to show this particular piece. This shows proper tire inflation. This is correct where you get full road contact. This is underinflated where the center is convex inside there, or concave. Then this is overinflation where you've got a convex tire contacting the road. So use the manufacturer specs as found on the label, normally on the driver's door jamb. Pretty self-explanatory. This will be included within the documentation for our tire fundamentals packet. Okay, next, tire rotation. There's generally two considerations with tire rotation. The first being, does the vehicle have 4 tires or does it have 6? 6 would be a dually pickup, okay? If it has 4 tires, the second consideration needs to be, is it front wheel drive or rear wheel drive? Front wheel drive is not going to apply to the 6 tire configuration, so we don't need to worry about that. The only place we need to worry about it is with the 4 tire system. Now basically the idea behind tire rotation is that tires wear at different rates based on where they're at on the vehicle and what function they're performing. If they're a drive tire, they are going to wear more aggressively because they're pushing or pulling the vehicle. Okay, if they're a steering tire, the entire tread's not going to wear as quickly, but the edges will wear more quickly because the edges are scrubbing to get that car around a corner. Okay, so we want to periodically change the position of the tires in order to get even tread wear. How often do we do that? We do that typically anywhere between 5 to 10,000 miles. Now the reason I say between, it depends on the customer's driving habits, how they use the vehicle, how hard they corner, how hard they accelerate. All these factors come into play. So it really needs to be something that's done on a case-by-case basis, but the general standard needs to be 5 to 10,000 miles. If it's a customer that drives in town all the time, they're going around corners a lot, you know, mail carrier, whatever the case, that vehicle most likely needs rotations every 5,000 miles in order to keep the tires wearing properly. If it's a vehicle that goes down the highway all the time in a straight line, cruising, chances are it doesn't need it nearly as often. It's not going to need it nearly as often, and it probably doesn't need it more often than every 10,000 miles. The sticky situation comes into play depending on what oil change interval people are using. If they're using a 5,000 mile oil change interval and it's marginal at 5,000 miles where they need their tires rotated, we should probably go ahead and do it. If we think that 10,000 is going to be too long. On the other hand, if 5,000 they still look good, then we can go out to 10 and do it every other oil change. If they're like a Chevy pickup that's doing a 7,500 mile oil change, then our standard needs to be that we recommend it every oil change. Pretty simple. Typically people are not going to come into the shop for just a tire rotation. Toyota's trying to get people to do that. I don't think it's working. I don't see it working. I mean, you've got to have a really dedicated customer. Tire rotation is something that's, for whatever reason, a little bit hard to understand or maybe hard to see the value in for a customer. The people that are really interested in tire rotation are the people that want a good ride out of their vehicle. That's the biggest, you know, that's the biggest motivation I've found over the years to keep the tires rotated. People that don't want the uneven tread wear causing poor ride. Okay. So that's how often, every 5,000 to 10,000 miles, and it needs to be evaluated based on the customer's driving habits. This can be done during an interview by the service advisor, or it can just be looked at by the tech, either way. The patterns that we use, the goal is to change the position and also change the direction of the tires periodically. The best way to do that on a four-wheel drive or all-wheel drive vehicle, this is going to be more or less our standard rotation. We take the rears to the front and we cross the fronts to the back. Okay, pretty self-explanatory. Then with a front-wheel drive car, it's the same thing, just the opposite. Instead of crossing the front tires, we cross the back tires. All right. And then in a case where you have directional tires that are only intended to be turned one way, the only thing you can do is go front to back with them because you can't change sides. Okay. Now the one instance that is not on this will be in the packet. The one instance that's not dealt with on there is the occasional vehicle that runs a different size tire on the front than on the back. This is more in your sports cars, that kind of thing. Like, you know, and it's got to be a pretty crazy sports car, Corvettes. I've seen it on some like Nissan 350Zs, some things like that. But it's pretty rare. but pay attention for it if you're working on a sports car. And obviously you can't rotate front to rear if the tire size is different front to rear. The one thing you can do is rotate side to side. That's if they're non-directional tires. A lot of times on a sports car they are directional. So without dismounting the tire and physically remounting it on the opposite rim, flipping the tire over, there's no way you can even change direction with those. So they're pretty much, you buy a sports car, you're going to be buying tires. Okay, dually. A dually gets a little more complicated because you're more likely to have mismatched tread front and rear. It's pretty popular to run a more highway tire on the front with an all-terrain or mud tire on the rear, especially if it's a two-wheel drive dually. People will often do that. In those situations, we have to be careful what we do because we don't want to put a mud tire next to a highway tire on the rear. That's just not going to be smart. And not only that, but it doesn't serve the customer's purpose of putting the more aggressive tire on the rear for better traction. So what do? This diagram is going to show the different options for dually tire rotation. Okay, the first option, which is seldom used, is just going to be rotating the rear tires side to side. That's going to be seldom, if ever, used. Okay. Number two, for irregular tire wear, the most common use of this is going to be like after we do an alignment. If the front tires were cupped and we're wanting to square them up, we can move them to the rear and bring two of them from the rear to the front. And if you go from front to outside dual here, you're also going to reverse the direction on both of those tires. Okay. The standard dually rotation is going to be pattern number 3. Pattern number 3 takes the outer dual to the inner dual dual to the front, and the front to the outer dual. So you are changing position of all tires, but you're also changing direction of the front and the outer dual. The inner dual is going to remain going in the same direction, but move to a different position. Okay. One thing to note about this one is they're never crossing them across the vehicle. All right. I don't know. There could be some argument for doing that, but typically it's just not necessary. All right, the last is going to be used in that condition I talked about where we've got a mud or all-terrain tire on the rear and highway tires on the front. And this is going to be that we rotate the rears and we just take them side to side, and the same thing with the front, side to side. And you can go a step further with this, and I guess it depends on how you analyze their diagram, but if you take this outer and make it the outer over here, then you've reversed direction also. So you can actually reverse direction and position by using that one, and leave it up to your judgment to decide how you want to do that. But anyway, dually tire rotation patterns, this will be in the documentation for tire fundamentals. Okay, rotation patterns, rotation frequency, those are all covered. The next and most complicated concept is going to be uneven tire wear. Uneven tire wear typically has 4 causes. Okay, the first cause would be improper inflation. Second cause would be improper alignment. Third cause, worn out steering and suspension parts. Fourth cause, driving conditions or manufacturer defect. Okay. Now, there are two types of wear that are associated with inflation. Those would be center wear and shoulder wear. Both of these are illustrated in this. This will be in the packet. Shoulder wear is caused by underinflation. The outsides of your tire are contacting the highway, but the center is not. Center wear is caused by overinflation. The tire is overinflated, so it's actually curving outward, convex shape, and only the center contacts the highway. If you see those wear patterns, that's caused by tire pressure. All right. So those are the two that can be caused by tire pressure. The two that can be caused by alignment are going to be the feathering is going to be the first. Feathering is when you have a wear condition that gives you a rounded edge on one side of the lug of the tire and a feathered edge on the other, and that's going to be the leading edge, the trailing edge. This is as you're going down the road. This is going to be caused by either a toe misadjustment or a pull, meaning that they're having to fight the vehicle to keep it in the lane, and they're having to correct all the time, which has the same effect of the toe being out of adjustment. So that's one of the most, probably the most common alignment related uneven wear. The next alignment related uneven wear pattern is tapered wear. This is caused by camber being out of adjustment. Basically, you make a wedge shape out of the tire because camber is the lean of your wheel, in or out. So depending on which way it's out of adjustment will depend on which edge of the tire is carrying the load of the vehicle, and the edge that's carrying the load will wear more quickly. Okay, the next two uneven tread wear conditions are going to be caused by worn out steering or suspension components. The first one, and this is the one that everybody always talks about, is cupping. People commonly call it chopping. They'll tell you that their tires are chopping. Okay, this is what it looks like. Typically, it'll be every other lug of the tire is worn out, and then the lug in between looks good. And often you'll get a sawtooth type pattern to them also. This is caused by worn out steering or suspension parts. The tire is wobbling or hopping a little bit going down the road, and it typically shows up on just one edge of the tire. Okay. The next one caused by worn out parts is diagonal wear. Okay. This is where you get a band of wear, stripe of wear that goes all the way across the tread of the tire. And just like cupping, there's usually a worn spot followed by a not worn spot followed by a worn spot all the way around the vehicle, or all the way around the tire. That is caused by worn out shocks. That tire is hopping down the road. Why does it wear diagonally? I don't know, but that's the way it does it when that tire hops. Okay, has to do with the geometry of the suspension lifting off the pavement. But anyway, diagonal wear equals worn out shocks. Okay, the next category of possible wear is driving conditions or manufacturer defect or whatever, tire defect, tire damage, whatever the case. First one's going to be flat spot wear. This is caused by driving conditions, a panic stop, a locked up wheel, whatever, something that the driver did that caused this wheel to lock up, and it made a single flat spot on the tire. What can we do to fix this? Replace the tire. That's all you can do. Okay. The next one, and this one can be a little bit confusing, is a different type of flat spot. but this is caused by like a broken belt. It'll only be in one spot, maybe a couple in the tire, but it's caused by broken belts, something like that, defect, damage to the tire. Okay. Now I want to spend a little bit more time on feathering versus cupping. These are going to be the two most common uneven tread wear patterns that you will find, and these two get confused often because everybody, especially the customer or the uneducated service professional, looks at them and can't tell the difference, and they just say my tires are chopping. Okay, well, we try to avoid the term chopping because chopping is not specific. We use feathering or cupping. Now, how do we tell the difference? Feathering versus cupping. Feathering, leading edge smooth or rounded, trailing edge sharp, happens on every lug. Cupping, we have wear typically every other lug. It's not even around the tire. That's cupping. If it's even around the whole tire on every lug, that is feathering. That is caused by toe or pull. This is caused by worn out parts. Okay, a few key points. Both occur on just one edge. You typically will not have feathering on the inside and the outside. You typically will not have cupping on the inside and the outside. It should be on one edge or the other. Okay. Feathering is on every lug. Cupping is usually every other lug or other pattern, but almost never on every lug. All right, it just doesn't happen that way. If you get a worn out part moving, it doesn't move so quickly that it affects every lug of the tire. Feathering equals a toe or a pull. Cupping equals worn out suspension parts. Now, it gets a little bit trickier, especially in this part of the world where we deal with a lot of mud and all-terrain tires. Okay? Is that feathering or cupping? Take a close look at it. Feathering or cupping? Well, let's analyze it. Is it every lug? Or is it every other lug? It's every other lug, right? But if you look closer at it, is it really every other lug? Every lug is worn the same, but every other lug is worn more severely. Okay? So this actually is feathering. Now, here's why. On a mud or all-terrain tire, feathering can be deceptive. Reason being, when you have a wide void followed by a small void, and then another wide, then another small, and so on, these two lugs can behave like a single lug. Okay? So if you look, it's definitely feathering. We've got a rounded and a sharp, rounded, sharp, rounded, sharp, but it has worn the leading lug in the two lug pair lower than the trailing lug. Okay? So that's it. So if you look at this two lug pair as a single lug, you'll still see feathering because the front edge is worn down more than the trailing edge. But then you also see it at the break between that two lug pair at that small void. You'll see a change in that wear between the two lugs also. So this can be deceptive, but this is feathering. Cupping is always going to be more severe. And on a tire like this, oftentimes your two lugs that are side by side will act as a single lug when it comes to the cupping wear also. So anyway, pay attention, especially all-terrain tires, some mud tires. They will have two lugs right next to each other that will behave as a single lug. Okay. Last thing to talk about, I said I would come back and hit on this, tire size. Tire size is typically in what they call the P metric system. That's what we use nowadays. Radial tires follow the P metric system. It will be comprised of a few key pieces of information. And those are going to be the tread width, the aspect ratio, the rim diameter, and then your load rating. Okay? Very quickly. The top one, that's passenger car. That's what the P stands for. 265, that is tread width in millimeters. 75, that is the aspect ratio as a percentage of the tread width. And then R means radial. 16 is the diameter of the wheel. Okay, the next example, LT, light truck. Same information, tread width, aspect ratio, wheel size. In the last instance, this one is also light truck, tread width, aspect ratio, wheel size, and then ply rating. Not all light truck tires will include a ply rating at the end of the tire size, but some do. So, tread width, aspect ratio, rim size, and then tire type. Okay? Make sure that you understand that. Make sure that you always know what the vehicle is supposed to have. And then if somebody is going from a passenger car to a 10-ply tire, you're going to have to sometimes deviate from the specified tire size, but we need to keep it as close to the overall size as possible. There are conversion calculators available online to help you with that if you need. So, okay, I think that covers it for tire fundamentals. All those documents that I showed in the video are going to be part of the packet that goes along with this that would go into your employee manual, and it really is key to, you have to understand this stuff to be able to understand steering and suspension diagnosis and alignment. So tire fundamentals, especially tread wear patterns, are a key piece of knowledge before you can really start working on several systems of the vehicle. So be sure that you understand tread wear patterns. You need to have that information down cold. Whether you're a service advisor or a tech, you need to be able to speak intelligently with a customer and with each other. So, thanks for watching, and make sure that you understand tire tread wear. Thank you.